All right, I've got another warm up for you, a little bit of review and a bit of looking forward into our next section. So give yourself a few minutes, pause the video. All right, hopefully you paused the video. Let's go ahead and give this a try. I hope by now, maybe you can actually eyeball this one. If you look and you see, hey, the degree of the polynomial on the bottom is bigger than the degree of the polynomial on the top, and x is going to infinity. Well, in this x going to infinity case, that's enough to actually know that this thing is going to be a 0. But let's do this the thorough way, shall we? I'm going to multiply top and bottom by, or divide top and bottom by the same thing. So I'm going to pick x to the 4th. X to the 5th also works just fine. Really, the degree of the top or the bottom both turn out to be fine. So let's go ahead and do that. We get the limit as x goes to infinity of, dividing this through, I'm going to go faster now. It looks like I get a 1 minus 3 over x cubed all over a, oh my gosh, I made a mistake. I'm going both by 4. All over 1 over, oops, looks like we have an x plus 2 over x to the 4th. There we go. So skipping a step or two on how that's on showing that division, because I think we're getting more mature at it now. Looks like this is going to go to 0. This is going to go to 0. What I'm left with is this limit as x goes to infinity of 1 over x. So it looks like I have a 1 over infinity situation here. 1 over infinity in the limit, at least, is a 0. Great. Okay, next up, one of these where we have a square root involved. Again, I'm going to let's pick the easier one. I see an x squared. Let's get rid of that. Okay. As you do more of these, you learn to eyeball these as well. But we'll go ahead and do it the long way. So the limit as x goes to infinity of, when I bring in that x squared into the cube, remember I need to multiply that 2 by that 3. And so I get x to the 6th over x to the 6th plus 1 over x to the 6th. Because it's a cube root and I'm bringing an x squared in. Okay? Because the cube root of x to the 6th is x squared. On bottom, it looks like I just get a 2. All right. This thing is going to 0. This thing is going to 1. So the cube root of 1 is 1. Looks like I'm just going to get a 1/2. How nice is that? All right. Nice. An old familiar friend, x to the infinity of e to the negative x. Okay. It does help if you know what e to the negative x looks like. But if you prefer, if you want to do this algebraically, sometimes it helps to see this. This is 1 over e to the x. Negative exponents mean take the reciprocal. This now looks like 1 over infinity, a constant over infinity in the limit at least. It's an ugly infinity. In the limit at least is going to equal 0. Nice. Okay, so right about now, people start getting excited about limits at infinity, and they forget that a lot of these things we're doing only work if x is going to infinity. So it's often a good idea to go back and do some limits that aren't at infinity, that are at limits where x goes to 0 or something else, to realize that these rules and these tricks don't apply in those cases. Right? It doesn't make sense to divide everything by x to the 4th if x isn't about to explode. Okay. This last one is just a warm-up for what we are about to do in this next section. So f of x is x squared. F of 1 plus h is going to be something squared. This is a composition. Minus something squared all over, and let's clean up this bottom right now. 1 plus h minus 1 is just h. Okay, so in that first f where there was an x, it looks like I'm plugging in a 1 plus h. Okay, and in that second f where there was an x, I'm plugging in a 1. All right, nice. We're halfway there. It is very important at this point that you don't just try to bring in this squared. This squared does not just square the 1 and the h. We actually have to FOIL it. If you continue to make that mistake, you're going to destroy problems. You'll get wrong answers, but also you'll have done something that so oversimplifies things that none of your work really is going to demonstrate any knowledge. So it is a big deal. Let's FOIL this out. Looks like I would get 1 plus 2h plus h squared. FOILing fast is your friend. 1 squared is a 1 with a minus out front, so this is minus 1 all over h. Looks like those 1's cancel. Now we're at a place where I could factor out an h from up top. Okay, and this is really the preferred way of canceling out things from numerators and denominators, is to make sure that you can actually factor them out so that you can cancel them. What's left here is a times 1. And 2 plus h over 1 is just 2 plus h. Much nicer. Now hopefully to yourself, you're saying, oh, but there's a caveat here. These can't actually be the same because they are not the same when h is 0. And that's true. The second we canceled out those h's, we need to include this is only true when h is not 0. Our original function is not defined when h is 0. And so what we get out also should not be defined when h is 0. Of course, the point of limits is to look at something like that and say, that's just a hole. That's our favorite kind of discontinuity because it's clear what should be the value when h is 0. When h is 0, if we want to fill that hole, the value should be 2. And that's the only real value that makes sense. All right, that's it. I hope you enjoy the next section. It's a good one.